Welcome, ladies and gentlemen, to the very first section of Chapter 2, 2.1 Relations and Functions. Yes, we have covered relations and functions before, but now we're going to dive a little bit deeper in the material. And this first section is a little bit definition heavy, so just bear with me, hang in there while we cover all these definitions. Our very first vocab word is function. And if we remember back, we know a function is a relation in which each element of the domain is paired with exactly one element of the range. And now we have different types of functions. We have a one-to-one function, we have an onto, and it can be one-to-one and onto. So one-to-one is where the element of the domain, each one of these guys, is paired with only one in the range. And notice how our range, you could have one guy left, but each of the domain is paired with exactly one. And now an onto, you can have each element in the domain going to an element in the range, but two elements in the domain can go to one element in a range to be an onto function. And it can also be both. It can be one-to-one and onto. So let's take a little bit deeper look into those math definitions. So one-to-one, each element of the domain pairs with exactly one unique being the keyword element of the range. So D is unique to 3, C is unique to 2, B is unique to 1. Onto, each element of the range corresponds to an element of the domain. They all take up one of the range, and both, each element of the domain is paired to exactly one element of the range. So exactly one here, 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 and there. And each element of the range corresponds to a unique element of the domain. Just know that all your ranges are used up. So let's take a peek at this. So for number one, we are asked to state the domain and range of each relation and then determine whether each relation is a function. If it is a function, we're asked to say if it's one-to-one, onto, both, or neither. So here we go. Domain, remember your domain is all your x's. So here, my domain would be -6, -5, -3, -1, and 6. And now my range would be all my y's. So my range would be -1, -9, -7, 7, -9. So now, is it a function? Is there any x? Is there any x that goes to two y's? No, there is not. So yes, it is a function because each element of the domain is paired with one element of the range. Is it one-to-one? Well, does our domain go to different elements? And the answer there is no, because if we look at -5 goes to -9, and also 6 goes to -9. That's fine for a function, but it just doesn't make it a one-to-one function. And then finally, is it onto? Your answer is yes, because each element of the range corresponds with an element of the domain. There is not a wasted range, so it is an onto function. Let's take a look at part B of it. Now, is this a function? Well, let's look at it. We have our x and we have our y's. Now look at your x's. Notice how this 2 goes to -2 and this 2 goes to +2. Is that allowed in a function? And you guessed it, it is not allowed in a function because 2 is to -2 and +2. Now let's look at number 2. Let's look at a graph. What is the domain? Remember, domain is all our x values. So our domain is, we're looking at x values. What is the value of this point right there? Well, the x value would be 0. What's the x value there? Would be 1. Then we have 2. We have 3, and we have 4 for our domain. How about our range? Now we're looking at the y values. Well, that's down, -1. This is up to. That is up to. And then we're up all the way to 4 and to 3, so there's our range. So is this a function? It is a function because each element in the domain is paired with one element in the range. Is it 1 to 1? 1 to 1, our answer lies right here. Can that happen? Can we have two x's go to one y to be a 1 to 1? That is to be a 1 to 1? No. And it's stated right here. And then is it onto? Yes, because each element in the range corresponds with an element in the domain. Besides mapping, guys, a graph and given points has to be onto. That's a little hint. Again, a graph and when you're given your points, and even in a table, they all have to be onto functions. Now, we're going to go into some relations. A discrete relation is a relation in which the domain is a set of individual points. So can we see here, and I'm going to get my blue marker, that those are individual points. This point is -1, 1. This point is 1 1/2. This point here is 3, 1. Those are individual points. So that is discrete. When you have individual points, this is a discrete graph. And same thing here, all these dots aren't connected because our graph goes from here to here and then jumps up to here and goes to there. So it's not continuous, which leads us into a continuous relation now, is the domain has an infinite number of elements. So it's basically been what you're dealing with up to this point. So a straight line would be an infinite number of solutions because it keeps going. A quadratic graph of a quadratic equation, it keeps going, would be a continuous relation. If all the dots are filled in, it is a continuous relation. Now that gets us into another vocab word, the vertical line test. The vertical line test basically tells us if the graph is a function or not. And how does it do that? Well, I'm going to take this vertical line, and if it intersects the graph in more than one point, it is not a function. So can I place this vertical line on more than just one point at any time? Now it may look close here, but it is just going through one point. So since this graph passed a vertical line test, that line did not go through any 2 points of the graph at the same time, it is a function. And what kind of function is it, or what kind of relation is it? It is continuous because there are no separate points on this line. Looking at number 2, can I take this line and put it through any 2 points? Let's see, I have 2 points right here. So is this a function? No, it is not a function. And then what kind of relation would this be though? If it is, or it is a relation, but what kind of relation is it? It is a discrete relation. Now going to number 3. Does it pass a vertical line test? Can I place this line through any 2 points of the graph? I cannot, so since I cannot, it is a function. What kind of relation is it? It is a continuous relation. And then finally, can I place this line through any 2 points on number 4? Yes, I can. Right? I leave it there, and notice how that blue line passes through that point and that point all at the same time, so therefore it is not a function, but it is a continuous relation. Now a couple more vocab words here. We have an independent variable, and in a function the variable, usually x, makes up the value of the domain. It's whatever variable makes up the domain. Dependent variable, now it's called dependent for a reason, depends on the independent variable. The dependent variable depends on the other variable, stated here. And then we are also going to get into some function notation, which basically changes a y to an f of x. So if it was written like this, y equals 5x minus 1, function notation changes that y to f of x. So let's try some function notation. Here, our f of x function is given to us as 3x minus 1, and our g of x function is given 4x plus 2. So let's go ahead and try to solve for a. Now, when we are given this f out in front, that means I have to use the f of x function. Well, since it says f of 5, I'm just going to go ahead and write it like this. If you don't want to put that 5 in there, that's fine. That's completely fine. You don't have to. It's not illegal, but it is how a lot of mathematicians write it. So if we put 5 in for that x, what are we going to put in for our x over here? It's just going to be another 5. So it's 3 times 5 minus 1. All I did was put this 5 in for that x, and so now we solve. We have 15 minus 1. That simplifies to 14. And so f of 5 equals 14. Well, let's try part B. Now that's saying g of 5. Well, I'm not going to use my f of x function because it's asking for the g function. So now it's going to be g of 5 equals 4 times, and it's no longer x, it's 5. 4 times 5 plus 2. And so we keep simplifying. This is 20 plus 2, which simplifies to 22. And so now g of 5 is 22. And that does it for section 2.1, Relations and Functions. Good day.